So on the quiz, when it's the one equation where you gotta find the force of like the sun and the earth acting on one another, for the radius squared, should that be the distance that's given in the problem, or are we supposed to do something else?
Okay, so in this case you can assume that it is the distance between the centers of mass. There's a diagram in the book that shows this, and this is M1, M2. The distance that matters is the distance to the center of each object. So R.
Okay.
Now in astronomy, when we're talking about planets and the sun, we do go from center of mass to center of mass because that's the most useful dimension to deal with. But if you're dealing with a problem on the planet Earth, like let's say we do that problem where here you are on the Earth, and it's radius of the Earth, and here you are standing at sea level, right? Then you would use the radius of the Earth as your distance.
Okay.
But what if you get up and go to the ISS, which is way up here, and I don't know, this is going to look like a TIE fighter, but whatever. If you're at some altitude h, then you're going to use RE plus h in your formula. Okay. And just to be explicit, for ISS, the FG is going to be big G, mass of the Earth, mass of whatever it is you're measuring up there. It might be the ISS divided by RE plus the altitude squared. And that's a fair game problem. That's actually a pretty good problem, because what you find is you go up on the ISS, you see all these videos of these astronauts up there. They're in what's described as a microgravity environment. So everything's floating around. But you work this problem and you put in the altitude of the ISS, the force of gravity up there is not that much different than it is on Earth. It's a little less, but not terribly much. It's not zero, which is what those videos would imply. So what's going on, and this isn't going to be on your test, it's just sort of a gee whiz thing. What's going on is that the gravity is enough to keep you in a circular orbit, so that everything's accelerating at the same rate. And so it is a weightless environment because the acceleration is all the same. The equivalent environment would be go stand in the elevator and cut the cable. Now you and the elevator are both accelerating at the same rate, and you'll appear weightless until you're suddenly not.